Hi there, this is GCSE Electricity, Lesson 14, The Dangers of Mains Electricity. It's a very wordy one this, lots of note taking and stuff to remember, and then the next 4 lessons I believe are all going to be heavily calculation based. So the objective is to understand what the dangers of mains electricity are and to explain different methods employed to reduce the dangers. So remember to pause at any point if you need to make any notes. The dangers of mains electricity. So the 2 main dangers of mains electricity are, number 1, fire. This can be caused by too high a current flowing along cables or through appliances, and a fuse or circuit breaker is used to limit the current to a safe level. Secondly, electrocution. This can occur when contact is made with a live wire. Death can occur if a current above around 100 milliamps or 0.1 amps flows through the body. The earth wire in combination with a fuse or circuit breaker can prevent electrocution. So next is fuses. A fuse is a length of wire designed to melt, and so breaking a circuit when the current passing through it goes above a certain level. So there's some fuse wires, and as you can see, the different wires, the 5 amp, the 15 amp and the 30 amp, they all have different thicknesses. So obviously the 30 amp fuse can take more electrical current than the 15, and the 15 can take more than the 5. So typically we'd have 3, 5 and 13 amp fuses that are used in 3-pin plugs. So the thicker the fuse wire, the greater is the current required to cause it to melt. Fuses are only supplied with a limited number of ratings. And here's a modern circuit symbol for a fuse. So what about a circuit breaker? A circuit breaker is an electromagnetic device that breaks a circuit when the current goes above a certain value. So the one on the left, an RCD, residual current device, is a circuit breaker used with an individual appliance, such as a lawnmower. The one on the right is a circuit breaker in a consumer unit. So somewhere in your house you will have something that looks similar to that, maybe in the downstairs toilet or cloakroom, or in a cupboard somewhere, maybe downstairs in a basement, but you will have one somewhere. So here's a simple circuit breaker. So this will also link into the electromagnetism topic area, but let's have a look at it now anyway. So current normally flows between the terminals A and B through the contact and the electromagnet. So that's in normal operation. If the current in a circuit increases, the strength of the electromagnet will also increase. So basically it becomes a stronger magnet, and what it will do, it will pull the soft iron armature towards the electromagnet. As a result, spring 1 pulls apart the contact and disconnecting the circuit immediately and stopping current flow. So just like that. Then the reset button can be pushed to bring the contact back to its original position and reconnect the circuit. Remember to pause if you want to make any notes. So comparison of fuses and circuit breakers. Both can prevent fire by limiting the current flowing through a cable or appliance. Fuses are simple and are cheap to replace. Circuit breakers act more quickly than fuses and can be reset. Remember, a circuit breaker is based on, as soon as you get too much current, the electromagnetic strength will increase, which will cause the circuit to break, and then it can be reset. A fuse, you actually need time for the heat to build up and the wire to actually physically melt, which is obviously a little bit longer in duration. So we talked about the earth wire in another lesson that was previously done. Might want to make some extensive notes on this one. So appliances with metal cases such as a tumble dryer are usually earthed by having the earth wire connected to the metal case, as you can see on this diagram. Normally current flows to and fro between the live and neutral wires through the heater of the hairdryer. So the metal case is at 0 volts and at the moment is safe to touch. If the live wire becomes loose inside the dryer, it might touch the metal case. The metal case would now be dangerous to touch and could give a fatal electric shock. However, the earth wire provides a low resistance path to the ground, and electrical current will always take the path of least resistance. So a large current now flows through the fuse and causes it to melt. And the dryer's metal casing is now isolated from the live connection and is safe to touch. So the fuse and the earth wire will work in tandem together. So what about double insulation? So many electrical appliances have casings made from an insulator such as a plastic rather than metal. The electrical parts of the device cannot therefore be touched by the user. So the appliance is said to have a double insulation or be doubly insulated. Such appliances will only have a 2-wire cable as they do not need the earth wire. So it might look something like this. So we've got the neutral, we've got the live, still got the fuse, but there's no earth because the earth is not required. Plastic case food mixer will have double insulation. And there's a circuit symbol that looks like this. So what you could do is in your house is find something like this plastic food mixer or a blender or anything that has a plastic casing and see if you can find that symbol. It's either on the device or on the plug itself. Right, let's finish with a word fill, closed exercise. So if you want to pause and have a go now without the keywords, and remember you can either write the full notes out to keep a comprehensive set, or you can just write 1 to 7 and put the keywords in the correct place. If you want the help words, they're going on now. And then I'll take you through the answers. So 2 dangers of mains electricity are fire and electrocution. Fires are caused when too high a current is allowed to flow along cables. The current can be limited by placing a fuse or circuit breaker in the live wire. The earth wire is used to prevent the metal casing of an appliance from becoming live should a wiring fault occur. A large current flowing down the earth wire will cause the fuse or circuit breaker to isolate the live connection. Bit of a wordy one that, but I hope you found it useful. Hopefully you've got some comprehensive notes and a more thorough understanding of the dangers of mains electricity. Thanks for watching, and I'll speak to you soon.